as I was making the key, I was recording. So if you're Diane isn't here. Loris, do you mind turning off the front? Thank you very much. Okay, so real quick, um, you already did this, of course, and you're patiently waiting. You make sure you catch it when I type in wrong, right? But I always take a second. Please take a second to double check if you typed it in wrong, right? You could be like by mistake go 8.5 or something, and then the whole thing is off, and you're going to be very frustrated, right? So you double check x squares, all of that. I'm going to guide you through a bunch, but you should know by now a degree of 2 results in a parabola. So it could be either one of these. If it's a leading coefficient is negative, right? You know it's pointing down. So we narrowed it down from one of these two to that. And now the y-intercept was taken straight from the equation, no calculator needed. And then I had to, this one has a turning point, right, which we call the vertex for a parabola. And then you go ahead and find that. We did. And we found the x-intercepts, right? And I always, if as soon as you use the calculator, you put in keystrokes, okay? And I had everything now that I needed to graph this thing. And I will just show you that zoom fit is sometimes it works, but sometimes it throws a fit. I think that's why they call it zoom fit, right? So zoom fit, sometimes it looks like your screen is freezing and it gives you a glimpse of it. It doesn't do a perfect job. So sometimes if you don't see anything, zoom fit might help you. But we already determined the window parameters yesterday. So let's change those window parameters. Negative 100 to 1,000. And remember, these do not need to be the same as mine. You might have different ones. Your graph might, oh, good that this happens. I'm glad this happens. Window range. I made a mistake on my window. Don't call me, right? You go to your window, it doesn't like something. I changed the scale, you see that? So I'm gonna just get rid of that. It was supposed to be negative 10 here to 10,000 on the Y max. So I made a mistake, try it again, and there it is. I will make Y2 equal to 0 because right then you find the x-intercepts right away. If you wanna look further down, maybe go in comparison to 10,000, 10 is so small, right? So if you want it to appear, if you want your x-axis to appear, you need to go in negative 500 or negative 1,000 maybe, right? And then you're going to see a little bit more down here. Okay, enough of that. Now we need to graph on paper, and this is just our guide, okay? This is your guide. This is not everything, okay? So you go here, and I provided you with grids. Do you like that? I'm sure you appreciate that. Because right now the purpose is to seriously purpose is to graph this on paper, right? You know how to do your scale. So if you look at your x, you need to make sure your x values, so your x-intercepts are included. So I'm going to 712 negative 1.7. You need to make sure you have enough room to fit this in. So I'm going to try here, right? If this is 200, if I go up by 200s, it will work just fine, okay? I will be able to, I have some room to spare, but the 700 will fit in there, no problem. You need to stay consistent with it. You can't just say, oh, I'm going to go -1 on the left, right? You can't do that. That's wrong. You're going to lose a full mark if you do that. So I choose to go every 5 boxes are worth 200. And then for the Y, what should I be looking at for the Y? Well, look at your y-intercept and look at your vertex. I need to be able to have a y value of 87, almost 9,000 on the positive end. So I'm going to go, let's see here, 2,000, will that work? 2, 4, 6, 8, no, that's not going to work. So I'm going to go 3,000, 3,000, 6,000, 9,000. Now we're talking, right? And you do a couple in the negatives. So there's a bit of an art to it. It takes practice, and that's really all that is to it. So I'm going to plot the x-intercepts first. So we have our first one, which is negative 1.70. It's so close to the y-axis, we're going to make it almost touch it. Just make a dot there. And then 721, you got to kind of imagine halfway is 700, right? Halfway between these two would be 750. So 720 is right about there. I don't need it to be exact, but if you can get it exact, I will be picky, right? If you can, if it's not where it's supposed to be, you will lose marks, okay? So you got to make those dots nice and clear, visible. I need to be able to see those points. You don't need to label them. You don't need to do that just because you've already done that. And now let's go ahead and find our vertex. It's 359. This would be 300 here. Halfway between 3 and 400 is 350. So it's somewhere in this neighborhood. So let's go up that line all the way to 8,700. Here I need to do a little bit of thinking. Between 6, so this would be 7,500 right about there. So 8,000 something is there. That is fine. Close enough. Okay. So there you have your 3 points. You have your intercepts, you have your vertex, and you still need the y-intercept. The y-intercept is your is 0.85. It's very close to the origin, right? It's very close. We put it there somewhere. Right? So you've got your all intercepts and the turning point, which we call the vertex. And here's the art, guys. You gotta kind of just go out a little bit and then curve down and make it go through it like that. And this thing opens up indefinitely, right? So make sure you indicate that. Don't make it go in like this. That's not right, because we look at the shape of your graph as well. You go back to the vertex, you go out and down, make it look symmetric, okay? Because this curve is symmetric. You ready for this? You don't need to include this in your graphs normally, but I need to talk about the axis of symmetry. Does that ring a bell? It's just the line, the vertical line that cuts it in half. Okay? This is called the axis of symmetry. You know what? Most of the time, we're not going to really talk about it. But the axis of symmetry has an equation. X is equal to the x value of vertex. Okay? So if you want to write that down, it would be, well, let's put the actual equation up here. X is equal to, what's the x value of my vertex? 359.68. I'm actually going to highlight that. I don't necessarily want this to show up on a graph, but sometimes the question will talk about axis of symmetry. You need to know what they're talking about. If you were to fold it along that line, this side and this side would perfectly match. Okay, that's symmetry means it can be cut in half. Okay, you're missing one thing. You would lose half a mark right now. Who can tell me what it is? Equation. There you go. There we go. So we're going to go f of x is equal to negative 0.067 x squared plus 48.197 x plus 85. So I have it there. And you're wondering, I don't know if you have, maybe you're just too busy paying attention right now, but I already talked about this here up here. Did you see this way up here? I kind of just give you a bit of a guideline. Hey, the domain that I want you to graph this on, the x values that should be included is between negative 200 and 800, and it naturally ended up being, right? If you think about negative 200 is here, 800. It just ended up working out that way. But right now, I'm not too picky with that. I'm just gonna give you a guideline so you don't like go into like the tens of thousands, right? I don't want you to go that. We're just zooming in on the intercepts and the turning points. How's that, right? You think you can handle that? Well, let's do a cubic. Let's do a cubic. I asked you to find all the important points already. And of course, this is already done. I'm just assuming you did it. And I will just clear everything and type that in. If you have a fraction, please use brackets so that you avoid any confusion there. And then it's x to the power of. To the power of is that hat button, right? And you got to be careful here. You see how the cursor stays up in the exponent? You need to go arrow sideways to come back down. And I'm going to tell you, if you don't spend some time this weekend to graph, you will probably struggle when we do word problems, right? So I'm not going to dwell too long on just regular equations, right? So we've typed it in. Before I graph, I want you to do this in your mind, right? In your brain, right? You want to look at the fact that this is a cubic, right? This is a degree of 3. Okay, so you should have imagined that this will either go like this. I kind of use a squiggly line, right? Like this. It'll go like this, or it will go up from left to right. That's kind of what you expect, right? And maybe I'll redo this part here. If you wrote this down, I apologize, but so it's a cubic, right? We expect this shape, and the leading coefficient is a, which is -4/3. And because it's negative, I'm expecting this to happen. And obviously the bends could be more accentuated, it could be smooth, right? It could have 0 or 2 turns, guys. It's either 0 or 2. So we'll figure that out by looking at our calculator. That's not important right now. So let's go ahead and graph it. Oh, one more thing. Let's write the y-intercept down right away, which is 0, -20, right? That's the point there. Those things you can tell right away without graphing it. Now hit graph. Okay, I did see something coming down here. Okay, I'm going to try zoom standard. So zoom 6, right? Zoom standard. Oh, that actually works pretty good. And you're like, hey, it looks like a parabola, right? You know, this is a cubic. So we're going to go window. I'm going to go further down, and I'm going to also go further up. I want to see more. Not bad, but it's still not, it still looks like a parabola. You're zoomed into one of the low points. Window, I'm going to increase my X max. I'm going to go 100. And I'm also going to increase my Y max to 100. You know what I'm doing, right? Like I'm slowly guiding you through it, but you can go faster, right? Like I'm a little bit, I'm pretending to be you right now. So I overdid it with my X max, but I still have to go a little bit higher with my Y max, right? So back to window I go. X max was overkill. I'm going to bring it down to 50. My Y max, I should go 200, right? 200, 150. Still not enough. One more. Enough is enough. 300. There we go. Now you're seeing all intercepts. You're seeing the turning points. Good to go. This is a perfect window in my books. So you figured it out good. Now let's go ahead and find the x-intercepts. I first focus on the intercepts, then I focus on the turning points. That's just how I do it. Okay. So x-intercept would be y2 is equal to 0, and then we go second trace 5, and we kind of you can do doctor's note style, right? Like the second trace, like it's fine. I don't need it to be nice and neat. And then Second, trace 5 for intersect. And I like this problem right now. Your cursor is way in the negative 4,600. And as you move left or right, you should be able to, when I move left, I'm coming back up, right? And you're like, let's say you're still lost. You're like, I don't know where this thing is. Try jumping lines up and down. I went up lines. Like if you keep going arrow up, it's going to cycle through your functions. So when you go arrow up, you jump to that next function you have, and you're close to this one right here. So I'm just going to hit enter. You got to watch out. Enter, enter. Sorry, I got to redo this. Sorry, second trace 5. I'm going to jump up, enter, 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 and there it finds. So you just have to hit enter 3 times until it gives you the intersection. So let's go 11.13, 0. I will help you later if you're stuck, okay? But right now, just follow. Second trace 5, one more time. I'm going to jump to the red line, go over to the next intercept, hit enter 3 times. That's 1.220. One more time, second trace 5. I'm going to stay on the blue, go to the other one there, enter, 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 and that is negative 1.10, 0. So I've got my 3 x-intercepts there. Remember, a cubic can have 1, 2, or 3, okay? But it must have 1. It will always cross it at least once, okay? Good. Now let's do the turning points. I will do let's do the min first. You know what we call that? Local min. Because if you think about it, there is no true minimum for a cubic, right? It keeps on going indefinitely. So this is a local minimum here. So you're going to go second trace. I'm going to write that down. Second trace minimum. If you select maximum, it's still going to try to find it, but it's going to be wrong. Okay, so you got to be careful there. Second trace minimum, hit enter. It asks you for a left boundary to that minimum. So imagine this is your minimum. You got to go to the left, hit enter. Then it's asking for a right boundary. Go to the right of it, hit enter, and then enter one more time. Do you see what it does there? I'm glad these things are coming up. Can you see that on your screen? I don't know. Sometimes it only does it for one calculator, not the other, but I'll show you here. That is a scientific. That's actually 8.07 times 10 to the negative 7. That's a very small number. That is 0 to us. Okay, so I will actually write that down. To the negative 7, negative 20. And this is just 0, right? This is just 0. So we will write it as 0, negative 20. Hey, isn't that our y-intercept? You notice that? They happen to be the same, right? The y-intercept also happens to be the lowest local minimum, the local lowest dip, okay? Local max, we go second trace max, obviously. Soon, this is going to be a word problem. So we're going to ask you, hey, what's the highest temperature reached throughout the day, right? And you're going to be like, oh, I think they're asking for the max, right? So let's go ahead and find that. Second trace max. And we're going to go up, find a point to the left of it. I hit enter, go over, past it, and now you're to the right of the max. Enter, enter. And so that point is 7.5, 261.25. So you've got your intercepts, you've got your turning points. You're good to go. You want to find more points? Like PC points? But you know you can do that, right? Allow me to introduce table. If you go second and then graph, dun dun dun, right? These are all points on your graph, by the way. Right? When x is equal to 3, y is 79, x equals to 4. So those are all points on your graph there, folks. So if you want more points, help yourself to that, okay? But I'm not going to do that. I'm just going to stick with this because these are the ones you must have. So let's go and find an appropriate scale. Make sure you put arrowheads because I did not do that part, right? You need to do as much. So x and y, call it something. Figure out your scale. I'm looking at my x-intercepts, and it's pretty good. It's not crazy numbers here, right? So we're gonna go 5, 10, 15. So every box is worth 1. It's nice and easy, right? I'm gonna do the same thing going to the negatives. Just a couple like that. And what about my y? I look at my intercept, I need to go down to negative 20 and as high as 261. So this is the one you need to focus on. So let's see here, 100. Oh, hold on. I think I can do 50, right? No, that won't work. 50, 100, 150, 200. I'm going to run out of room. So I got to go 100. You can go 150. You can go 75. It's up to you. I just don't like using. I like round numbers. So that means that you must go with the same scale, right, down to the negatives. And yet now you've picked the correct scale. If you are wrong by even 1, I have to take a full mark off. So make sure you take your time. Because some students are like, oh, negative 20, so I'll just go 5, 10, 15, 20, perfect. And you're going up by 100 here. You can't do that. So 11.13 is very close to 11, so just make a big dot there. 1.22 is right about there. And then negative 1.1 is right about there. So you've got your x-intercepts lined up. Let's do the negative 20. Here I think you can be precise because it's 20, 40, 60, 80, right? Every box is worth 20 here. You see that? That's when I hone in and I'm actually going to call you on it if you get it wrong. It needs to be exactly on that intersection there. And then the max is at 7.5, so 6, 7.5, so right about there. I make a little mark on the x-axis, and then I go up to 261. So this would be 250 right here. So 261, actually, right, you can go 220, 240, 260. This is the 260 mark right here. So I'm just above it. And now you can graph it. So you know you're coming this way, you dip, you go up, you come back down. I will focus on this part here that I know. So I'm going to curve like this and then up. Don't go straight to the point. Kind of go sideways and then in like that, out a little bit, through that x-intercept, and then I would stop there. Don't go too far down because then you might be off, right? Just go a little past it. Arrowhead, that is good. And then kind of do the same thing here.
Please excuse the interruption. Could all grade 9 students and their teachers please start making their way down to the theater for the Remembrance Day ceremony? Please all grade 9 students and their teachers start making their way down to the theater for the Remembrance Day ceremony. Thank you.
Couple of things here. Yeah, arrowheads must be on there when it's just an equation, no word problem attached to it. Very soon, that's not going to be the case. We're going to kind of cut it like this because we're just interested in quadrant 1. So you got to watch out for that. Is there something else I can warn you about? Oh yeah, I was doing my homework yesterday, and I need to. Do you remember roots? What are roots? Not on a tree, but on the on polynomials. Roots are x-intercepts, and it comes up at one point. So I want to find a spot to add that. Can we go to page 7? Recall that x-intercepts is the same thing as roots. It's the same thing as zeros. It's the same thing as solutions. They're all interchangeable. So roots should not scare you. They're like, oh, they're asking for x-intercepts. How many zeros does this one have? Oh, don't worry about it. It's just asking how many x-intercepts. What are the solution? What's the solution to this polynomial? We're finding the x-intercepts. Okay, so don't let that throw you off. That's just what's happening there. So now you know why the book is so thick, because I give you lots of grids, right? I don't give you like 20, hey, graph these, good luck, right? You come up with the grid. I don't know, I want you to just be good at coming up with the scale and the points and graphs. So I will tell you what's up for the rest of today. I split this up into linear. So part A is linear, then you keep flipping through these questions, and then it's quadratic, and you keep, there's 4 of those, and then there are cubic functions. So what I would do right now is I would do one of each for today. Do a linear, do a quadratic, then do a cubic. And then maybe cycle through it like that. I wouldn't just spend time today doing all of the linears, because those are fairly easy to do. There are no turning points, right? And maybe do one linear, and then do one quadratic and one cubic, and so forth. And I have a video that I made that goes through 99% of them. I don't do all of them. But if you're stuck, you can watch a video, but I will also scan my key and post that. So if you don't want to watch the video, you can just go ahead and get the answers.